Hi, everybody. Welcome to my channel, Numbers with Nora. This is a channel where you can get math tutoring, math help, and then also all kinds of answers to homework questions or any kind of math troubles that you're having. For this specific video, we're going to be doing Algebra 2, Rational Roots Theorem Practice. I got this worksheet from one of my 2Ds, and so I'm just going to be doing a couple of these ones. Again, excuse me for my voice. I'm a little sick. So just bear with me. The book that I'm using for Algebra 2 is called Big Ideas Math Algebra 2. If you want the free link to that PDF, leave a comment in this video down below. So let's get started. So let's focus on this one. It says use the rational root theorem to list all the possible roots, then find all of the roots. Finally, graph the polynomial using the end behaviors. I'm not going to graph the polynomials fully, but I can show you how the end behaviors work and show you a chart of how to sit there and find the end behaviors. All right, so let's go ahead and start. So remember, our roots is just when our polynomial hits our x-axis and when our y equals 0. So this first one, you always want to make sure that your polynomial has all its degrees. So right here, we're missing the third degree. We have the second, we're missing the first degree, and we have our constant. So let's write it out so we make sure we have all of our degrees. So it'd be x to the fourth. And then we'll do plus 0, because that's our coefficient for that one, x to the third. And then minus 3x squared. And then plus 2. Now I sit there and I account for all of my degrees, fourth, third, second. Oops, I forgot one. The first degree. 0, x, and then plus 2. Okay, perfect. So now I account for all my degrees for fourth, third, second, first, and then my constant. So after I do that, now I want to sit there and list my p and my q's. Those are all my possible roots that can happen with this polynomial. So when I talk about p and q's, my constant is going to be my p. And then this one, my first coefficient of my highest degree is going to be my q. Okay? That looks more like an A. Let me write it so it's more like a Q. Q. And so I have P over Q. All right, so let's list out all of our P's first. So I'm listing out all my multiples of 2, okay? So I have plus or minus 1. That's a multiple of 2. Also plus or minus 2. That's a multiple of 2. And then for my Q, all my multiples of my Q are just 1, so just plus and minus 1. And this kind of sets up like all the things that we can test. Okay, so all the things I can test is plus or minus 1, because plus or minus 1 over 1 is just 1, 2 over 1, right? Plus or minus 2. Those are all the things I can test. Now I'm going to sit there and use synthetic division to go ahead and see which ones that we can test, okay? If you don't get synthetic division and I don't break it down enough in this video, leave a comment and I'll make another video of how to do synthetic division, but I'll try to walk through it as best as I can with this one. So let's go ahead and test positive 1. I always like starting with 1 to test because that's a possible root. So I start with a number that I'm going to test that's a possible root, 1, and then I make a box that's big enough to put numbers in my first row, my second row. My first row of numbers that's going to go inside of my synthetic division bar is going to be all of my constants, okay, of my variables, or all of my coefficients of my variables. So the coefficient of x to the fourth is just 1. My coefficient of x to the third is just 0. My coefficient of x to the second is -3. My coefficient of x is just 0. All right. And then I just have 2 as my constant. All right. First step I'm going to do is drop down my first number. That's just going to be 1. So I want to multiply my coefficient times the root that I'm assuming is a root. Okay. So 1 times 1, that's going to give me 1. I put it right here. And then I add these two numbers. 0 plus 1 is 1. And I start that same process again. 1 times what my possible root is just 1. Put 1 right there. -3 plus 1 is -2. And I keep going. -2 times my possible root, which is 1. So 1 times -2 is -2. And I get -2 here. All right. -2 times 1 is just -2. And this is the key moment. So 2 plus -2 is going to be 0. We always want to make sure we get a 0 as our last one. Because if we do, that checks off, and that means x equals 1 is one of my possible roots. Okay. Good. So now we continue from there. Now I have a lesser polynomial I can write with this information. So it always goes down 1 power than what we had before. So now I can write this as x to the third, because my coefficient is 1 for x to the third, plus x squared, because my coefficient is 1 for x squared, minus 2x minus 2. That's my new polynomial. Okay. 0. And so I'm going to use synthetic division again to find one of my possible roots. Okay. And so to do that, I already found 1 is one of my possible roots. So let's try -1, right? So let's try it with -1. And I'm using synthetic division again. Okay. So for this one, I list my coefficients in my first row when using synthetic division. And then -1 is just one of my possible roots that may be a root. And remember, our goal when using synthetic division is we just want to get a 0 at the end. Okay, so my coefficients for x to the third is 1, x squared is 1, -2 is my coefficient, and my constant is -2. So I start with the synthetic division again. I drop my first one down. That's 1. 1 times -1, that's going to be -1. -1 plus 1 is 0. 0 times -1 is 0. -2 plus 0 is -2. -2 times -1, that's going to give me 2. And I get 0, which is check. Okay. Gold. So then I also know that x equals -1 is also a root. All right. So now let's do another one. I don't want to run out of room, so I'll sit there and go over here. Okay. So now, again, my last one was to the third, so I know this new polynomial I'm going to write is going to be 1 degree lower. So this one belongs to x squared. And then I can put plus 0x, just so I can sit there and make sure I'm showing you every step. And then minus 2. Okay, but we don't really have to write that 0 there, so I can go x squared. And then minus 2. And remember, we're setting these equals to 0 because we're finding roots. All right. So I want to solve for this. Usually if this was like a perfect square, then I can do like a difference of squares by factoring. But I can't find the square root of 2, so I'm going to just solve this by isolating my x squared. I add 2 to both sides. I get x squared equals positive 2. I'm going to have to square root both sides to get rid of that exponent. So I get x. When I square root both sides, I always do plus or minus. Or minus root 2. Okay. All right. And so we can make sure we're right by sitting there saying our highest degree was 4. That means we're going to have 4 roots. Okay. We're going to have 4 times that our polynomial hits our x-axis. So it hits our axis as at 1, our x-axis at 1. It hits our x-axis at -1. And it also hits our x-axis at positive square root of 2 and negative square root of 2. Okay. And like I said, I'll talk a little bit about end behaviors. I'm not going to graph this one fully, but you know it's going to sit there and hit, excuse me, at -1, at 1. Okay. And then also root 2. What do I get for root 2 when I sit there? And let me see. Let me do that on my calculator. When I get a decimal for root 2 for graphing it, just a sec, root 2, 1.41. So that's a little bit like over here. We'll say that's 1.4 right now. 1.41. And then I get a -1.41. So that's like kind of where it's going to hit. 1.41. Okay. And so also here's like what I'm getting ready to talk about my end behaviors. And you guys can sit there and take a screenshot of this and save this for when you do your homework on the side. So when I have an odd degree, I'm usually going to get one arrow going up and one arrow going down, but this is a positive lead coefficient for my highest odd degree. So you're going to get x going from -infinity to infinity. When you have an odd degree with a negative leading coefficient, it's going to go the other way. You're going to have a -infinity and then going down to here. Okay. And this is something like you can look at and start to memorize. And then when I have an even degree, in which in this case for number 1, I do have an even degree because it's to the 4th power, then that means my leading coefficient, if it's positive, both of them are going to be pointing up. Even degree, and like say I have a negative coefficient for my highest even degree, then I'm going to be pointing down as my end behaviors. Okay. So since I have x to the 4th as my highest coefficient for that polynomial for number 1, it's an even degree. 1 is a positive coefficient, so we know it's going to be pointing up our end behaviors, okay? So if I go back up here, I know my end behaviors. I like to just draw my end behaviors first. They're going to be pointing up like that. And so it means the graph is going to go something like this. Okay, and see it hits all of our roots. So the graph will look something like that. And if you ever do want to check your graphs, you can go on desmos.com and then put in this polynomial right here. And you can check your graph and make sure it matches that graph on Desmos. And Desmos is 100% free. Okay, if you want more questions on Desmos, I can sit there and put it in the comment how to get to that website. So let's go ahead and do one more. I'll do number 2. Okay, just so you guys can get the hang of this. Yeah, let me make the eraser bigger. There we go. All right, so let's try to give 2 a shot. We're doing the same thing. Going to sit there and use the rational root theorem to go ahead and solve this. First thing we want to do is we want to identify our P and our Q, correct? So this one is my P. My coefficient of my highest degree is my Q. And we just want to see all the possible roots for this polynomial. Okay, so P over Q. All right, and let's see what we get. So let's list out all the multiples of 24. So I'll have plus or minus 1. Plus or minus 2 is a multiple of 24. Plus or minus 3 is a multiple of 24. Okay. Plus or minus 4 is a multiple of 24. Plus or minus 6 is a multiple of 24. Plus or minus 8 is a multiple of 24. Plus or minus 12 is a multiple of 24. And then plus or minus 24 is a multiple of 24. Okay. And now let's do so for our q, which is our leading coefficient of my highest exponent. Plus or minus 1 is a multiple of 2. And then plus or minus 2 is a multiple of 2. All right. And so what we do is it's kind of like we can list out all the possible multiples. I'm not going to take all that time of listing them all out, but some of the basic ones we see as plus or minus 1. Plus or minus 2. All right, because 2 over 1 is 2. 2 over 2 is just 1, and I already have plus or minus 1 listed there, so that's fine. 3 over 1, that's just plus or minus 3. 3. Now 3 over 2, that's a fraction, so that could be a possible root, plus or minus 3 over 2. Okay, now let's one more with 4, plus or minus 4 over plus or minus 1, that's just 4. So plus or minus 4. And then plus or minus 4 over plus or minus 2, that's just 2. And I already have 2 listed. So you would sit there and list all these out, and you'll sit there and see all your possible roots for this polynomial. So after we sit there and do that, now we have to go to the synthetic division and sit there and see where we can get 0, okay? I always like starting with 1. It's just easier to start that way. So let's start with our possible root as 1. Again, up here in my first list, I'm going to sit there and list down all my coefficients of my polynomial. So I have 2, and again, I have it all going from descending order at 4, 3, 2, 1, and my constant. So we're good to list them out. So 2, negative 3, negative 21, negative 2, and then 24. Okay. And so the first thing I'm going to do is drop my first one down. And I have 2. 2 times 1 is 2. And then I add these numbers. I get negative 1. Negative 1 times positive 1 is negative 1. Negative 21 plus negative 21 plus negative 1 is going to give me negative 22. Negative 22 times 1 is going to give me negative 22 again. Negative 22 plus negative 2 is going to give me negative 24. Negative 24 times 1 will give me negative 24. Positive 24 plus negative 24 is going to give me 0. So that checks out. I get a 0 at the end. That means one of my roots is x. One of my actual roots is going to be x equals 1. Okay. Perfect. And now since we eliminated one of our powers, we write down our new polynomial. Let's get rid of this. More space. So our new polynomial is actually going to be 2x to the third minus x squared minus 22x minus 24. right? So again, since I have a higher degree, it's going to be harder to kind of like factor this out. I wouldn't factor this out with grouping. Let's do synthetic division again, okay? And so for this one, we would go up there and pick another one of our roots, okay? Since I already kind of worked this out before, I know that -1 is going to work. It's not going to work, because if you do -1, then you're going to sit there and end up with another number down here that's a non-zero. Try to work that out by yourself, all right? If you get stuck, let me know. But I know for sure that one of the other roots is going to be -2. So if I do -2 and I do synthetic division with it, my coefficients are 2, -1, -22, and -4. And then I do my synthetic division again. I drop down, and then I have 2. So -2 times 2, that equals -4, right? -4 plus -1, that equals -5. -5 times -2, that's going to equal +10. +10 plus -22, that's going to equal -12. -12 times -2, that's going to equal 24. -24 plus 24, that's going to equal 0. So I know that it's a check. And I got to have x equals -2 as another one of my roots. Okay. Perfect. All right. Next, we're going to have to sit there and factor this, okay? Just for room, I'm going to block out this. Because now I'm going to have to factor. Okay. So now my new polynomial, after I sit there and do that, it's going to be 2x squared minus 5x minus 12. Now this one would be factorable, okay? And the way we're going to factor this, I call it the cross method, all right? So with the cross method of factoring, we use this method when we have a coefficient in front of our x squared, because usually when we don't have a coefficient in front of our x squared, I could sit there and find two numbers that multiply together to get my c term, but add together to get my b term. You can't do that when there's a coefficient in front of your x squared, so we're going to use the cross method. What I do during the cross method, I take my a and my c coefficients, and I multiply them together. So 2 times -12, that's going to give me -24. And then down here, I'm going to put my b variable, which is -5. So now my goal is to sit there and find two numbers that multiply together to get my a times my c's variable, which is 24, but add together to get my -5, okay? So two numbers that multiply together to get -24 is 8 times 3, or -8 will belong to the 8, because -8 plus 3 will give me -5. So I found two numbers that multiply together to get -24, but add together to get -5 at the same time. So the next step after that is we rewrite our middle term, okay? So my first term, 2x squared. And I rewrite my middle term, minus 8x plus 3x. Because again, if I do minus 8 plus 3, I get back my middle term, but I'm just rewriting it. And then minus 12, okay? So all I did was rewrite this. Now I'm going to sit there and use grouping to factor this. So I can use grouping. Okay. And if you are kind of rusty on factoring, let me know. I can make another video all about factoring so I can break that down. You can get good at that as well. So now I'm going to pull out my greatest common factor, pull it out. So I have 2x. It's my greatest common factor. What's left over is x minus 4. And I pull out my greatest common factor for my second binomial right here, which is plus 3. And then what's left over is x minus 4. All right. And you know that you're factoring, right, when you use the cross method, or even like this grouping method, is when your inside binomials are the same, okay? So next, I sit there and put these together, 2x plus 3. All right. And then write my inside ones together, x minus 4. Okay. Equal to 0. All right. And then remember to find my roots. I just set each one of my binomials equal to 0. When I set this one equal to 0, I sit there and subtract 3 from both sides and then divide by 2. So x equals negative 3 over 2. It's a possible root. And then set x minus 4 equals 0, add 4 to both sides, x equals 4. It's another root. Okay, so I found all my 4 roots, which is 4, negative 3 over 2, and the ones up here we found using synthetic division is 1 and negative 2. And we know those are all 4 possible roots because I know since my highest polynomial is 4, that means I should get 4 roots belonging to this polynomial. Now for the graphing the end behavior, notice that again, my highest coefficient is even. And then also my highest exponent is even. And then my coefficient is also more than 0 as well, okay? So that means that my end behavior is going to be pointing up like this, all right? So I only had time to do those 2 in this video. If you want to see the rest of these, I believe there's up to 8 of these. Just let me know, and I can sit there and put in the comments like pictures of how I work them out so you can check your answers as well. And then also I'll sit there and put a blank PDF of this end behavior so you can have it as well in the comments. All right. And then also these problems if you want to try to work them out yourselves as well. And remember, if you have any homework questions, any math questions, or need any homework answers or going over tests or anything with math, just sit there and leave a comment below or subscribe and leave me a message. Thank you guys. Bye.